Hey everybody, great to see you all here. Well, at least half of you all on the eyes. Super happy to be here at the first, I think, our first official GraphQL Foundation thing.
Supported, open, neutral GraphQL.
That's awesome. That's amazing. So happy to be here. I'm going to talk to you a little bit about some of this recent work that we've been doing, thinking about streaming use cases and using GraphQL subscriptions, how we're kind of approaching the problem, quick demo of what that looks like. This is super early. We'll be releasing this kind of experimentally. It's already out, still out as an experimental feature. But something that we've been just thinking about. I would love to kind of hear how you folks are thinking about that problem after the session, or of course, any questions that you might have. So I'm Tanmai. I'm the CEO co-founder at Hasura. We launched Hasura in July 2018 as an open source project. Our aim is to kind of make sure that data can be accessed easily over a data API. So whenever people have data and they're kind of thinking of how they're going to expose that with an API, or there's a data as a service use case and stuff like that, that's kind of where we think of Hasura adding value. We use GraphQL as an API to deliver that. And one of the use cases that we've been increasingly encountering is kind of the streaming kind of use case. So that's what I'm going to talk a little bit about. So just to motivate the problem a little bit, there's two broadish use cases, right? The first is that there's an increasing amount of information that's moving quite rapidly that needs to be consumed within a window of time, right? And this is kind of your typical events and changes, stock ticker type things, messages, right? Stuff like that. Logs and metrics on a page, or just logs and metrics data that needs to be consumed, right? I'll caveat this in a little bit, but so that's kind of one use case where the data is just fast moving, quote unquote, real time, or streaming, right? It's just, that's the nature of the data itself. It's not like all data is necessarily streaming data, but that amount of streaming data is definitely going up, right? Teams wanting to share that with other people over an API, stuff like that, or whether it actually makes its way to an application, all of those kinds of things. The second is, and the second place where people think about streaming is when there's a large volume of data. It's not really like a stream of data, but it is a large volume of data. And people do want to consume that volume of data, but they want an API to think about consuming that volume of data, right? And this is kind of like data extraction type things, right? Where they want an API that can kind of let them stream a large volume of data, right? And when I'm talking about large, I'm talking about like millions of records or like gigabytes of data and stuff like that, right? And people kind of want a nice API as an alternative to whatever else they've been doing, right? Which is like slacking together a file or something. So that's kind of the use case that I'm talking about when I think of streaming, right? What I'm not talking about directly, or maybe there are overlaps, but it's subtly different from this at-stream kind of use case that we've been discussing otherwise as a part of the GraphQL specification. I think there's a talk later today as well about at-stream and at-defo, right? So that's a little bit different. It's kind of more optimized for incrementally delivering data, especially for a use case where you have a page that's rendering and you do want that first byte load to happen quickly. The size of data that you might be consuming on that page is still app size data, right? You're not like looking at consuming like a gig of data and using an at-stream directive on it, right? So I'm talking more about like those first two use cases and not really third piece. So when we think about this kind of streaming, there's two problems. So on the consumption side, there's two problem areas, right? So on the consumption side, when people who want to consume this API, they want HTTP. They want a nice stateless protocol. HTTP has security around it. There's lots of client-side tooling, so that's great. They need an ability to kind of manage back pressure. Without that, talking about streaming is not worth it for substantially large cases. And of course, ability to recover from disconnects and not miss data, and all of the typical kind of problems that you'd want as on the client side, right? And then there's kind of this other part, which is not on the consumption side, but when you think about serving that stream, there's challenges on serving that stream, right? Which is you want to make sure that your service can provide over HTTP, can do back pressure, can recover from disconnects, can be stateless, can scale out horizontally and stuff like that. But what you also want to ensure as a service that is providing this is you want to ensure kind of authorization on what bits of the stream are being sent out to whom. Increasingly, people want enrichment. So there's an example of what I mean by enrichment there, which is, for example, let's say you're streaming messages that have ID data and user ID. you want that to be enriched with user, not just user ID, right? And the user has username and email, right? And then, of course, from a server that's serving this stream, not the persistence layer, but the service layer, you want to make sure that that can also scale, preferably can scale in a easy container scale out kind of way, right? So those are kind of some of the challenges there. Now, talk a little bit about kind of how we've been thinking about approaching this at Hasura, right? So the first piece, when you think about GraphQL, there are parts of GraphQL that make this really nice, right? One, GraphQL is a nice fit because HTTP and JSON, subscriptions is a mechanism. There's several ways that we can slice this, but we chose to use subscriptions. We use subscriptions for two reasons. One, WebSockets, and the fact that the WebSocket protocol is customizable to a degree, right? For example, if you want to handle things like back pressure, or you want to send custom directives that are a little kind of at the protocol level, but not necessarily at the GraphQL level, there are opportunities there to kind of bake that in between this GraphQL server and the GraphQL client, right? So subscriptions allow for a little bit of that. The second, and the way that we think about this, right, is that we want to reduce the streaming problem to a smaller set of primitives, right? And the key part of reducing this to primitive is to say that we want to be able to solve some of the, we want to be able to solve the functional problems that we talked about, but also address some of those non-functional issues that we brought up, right? The way that we want to think of this abstraction is that producers can focus on just producing that stream data, and consumers can focus on just consuming the data. And the stuff that I talked about in the middle, the problems with consumption, the problem with serving that, that piece is automated. So we don't want to interfere with the way the stream is modeled, but we do want to automate the thing that does the streaming and how that streaming happens, right? So that's the point at which we want to take care of the problem, and I'll show you kind of what and how we thought about that, right? So now the way Hasura works is that Hasura is essentially a metadata engine, right? And this metadata engine captures three key things, right? It captures, there's a modeling layer. So the model layer says, hey, here are these underlying models that you have. How do you want to map them into the models that you want to expose over the API, right? The second is the authorization layer, which is that each model has granular authorization rules that can specify who gets to access what data inside that model. And the third thing is that multiple models can have relationships, and then these relationships are composed into an API, right? So that's kind of the underlying building block that Hasura has. I'll go over a little bit of that, talk about kind of where this point of attack is, right? So this input of models, authorization, relationships is given to Hasura, and then Hasura creates this output, which is the high-performing GraphQL API, right, for those models. So let's just take a quick look at what that looks like so that I can kind of motivate the piece around this. So I don't know why I chose to use this example, but I mean, what's done is done. So I have a model called color, which I'm using to model. I could have had a better model here. So I'm using this to model a channel name. So the color that you see is the name of a channel, and the message that you see is the actual message that goes inside this, right? So it's like a messages model. Each messages model actually has a color name, which is a channel name, and the message name, right? So at the Hasura layer, and this is not with subscriptions or thinking about streaming yet, right? The way that we think about it is the first piece is to get this model, right? And I've already done this work, is to specify the metadata that allows us to take this underlying model and bring it to the GraphQL layer, right? So I've already done that. And because of doing that, I get my usual, you know, whatever, colors, go and get a thing, right? And let's just limit this to 10, right? This is just the usual, the first aspect of just modeling that does that, right? The second piece of this is, and again, in a part of the metadata, I just have the UI, the underlying metadata is JSON, is the permissions layer that specifies who gets to access what data, right? Now this bit is important because we want this to compose. So you see the permission rule here, which is in JSON, but gets compiled into the underlying query, which I'll show you how that works. But this rule says that if a user is trying to access a particular message, they can only read stuff from their channel. So the color and their channel name should be mapped together, and they can only read stuff that is in their channel. And I similarly have a rule for a mutation as well. So when I apply this authorization rule, and I turn that on, right? When I now run this query, I'm only going to get, let me change this to get the channel name here. I'm only going to get the reds here, right? And if I switch my user ID to a green, I'm only going to get greens here, right? The reason why I'm talking about this is because the way this works underneath it is that this predicate is getting pushed down into the underlying data query, right? So the technique that we use for authorization is a predicate pushdown. Now, predicate pushdown is a really nice technique in all of the use cases where it works, right? The idea is that each model that has this authorization rule, that authorization rule is converted into a predicate. That predicate is compiled into the underlying data query, and then the underlying data query that goes out actually has that where clause. This is kind of exactly what you would have done if you would have written this query yourself, right? So these are predicates. All of these authorization rules are predicates that are being pushed down, right? So we have this modeling building block, then we added this kind of predicate pushdown building block, right? If you're building your own system, you can visualize how this maps to a system that you're building as well, right? Same concepts. The idea, though, is that we want the same predicate pushdown capability when we think of streaming as well, right? We want this same building block to kind of compose when we think about that too, right? So that's kind of one building block or one composable block. The second composable block is relationships, which then comes into, which then becomes important when we think about enrichment, right? So what I've done here for enrichment or for showing an example here is I've created a relationship between the color model with the name of the color and some extra information about this color, right? So as a part of my metadata, I've created a relationship. Because of creating this relationship, I can now do things like this, right? I can say, hey, I want some more info, and this info is now coming in from the other model, right? So that extra piece gets added because of the relationship that I created, right? So again, the same building block that we were using for creating relationships, whatever mechanism that is, in our case, it's a metadata, it happens at the metadata layer. We want that same composition to happen when we think about bringing and having this when we think about streaming, right? So ideally, I want to be able to stream messages. I want the same authorization rules to be applied as predicates, and I want relationships to come in as well, right? So that's one important piece here. When we think about, okay, so that's kind of on the building blocks that we want to have. Now, if you flip over to the stream consumption side, and we think about how streams are consumed, in general, you'll see that all kind of streaming customers and clients choose to use streams in a variation of this essential concept that applies the same everywhere, right? The first is the consumer opens a connection, the consumer quotes an offset or a cursor value, right? So if you're familiar with something like a Kafka client or whatever, you quote a value of your last known offset or your last position in the cursor. So the state is maintained by the client in kind of that streaming case. The streaming backend, whatever the service that's sending out the stream is, it sends this data which is ordered from that offset, right? So it sends ordered data from that offset. This consumer that is consuming the stream keeps committing or storing their offset at checkpoints wherever they do it. Sometimes they do it within the streaming backend, sometimes they do it locally. Wherever they do it, they keep storing their offset at checkpoints to ensure that data is not lost from the stream, right? And you'll see the same idea and the variation of the same idea no matter what you stream, right? So whether you're doing like a backend thing from like a Kafka to a Kafka system, or even if you think about Discord had a really nice, the Discord engineering folks had a really nice post. It was a little dated, I think it's a few years now, of how they model messages and the messages model on Cassandra, and how that's kind of optimized for essentially being able to quote, letting a Discord client quote a particular offset, and then read data from that message model, right, which is underneath it is stored in Cassandra. But the idea is that when we think about from the client perspective, right, when you look at this model and you think about the underlying backend system, essentially consuming a stream is consuming incremental ranges of data. So if you think about what a stream model is essentially a data model that has this ability to specify some kind of sequential ordering and then say that the method of consuming that incremental range is extremely efficient and works well, right? And that's kind of what this problem reduces to. And that's how we think about the underlying primitive, right? So the underlying primitive is to say that on any streaming model, can we make it possible to consume incremental ranges of data easily, it'll scale, it'll work well, and we'll handle all of those kind of functional and non-functional problems that we talked about a few slides ago, right? Okay, so the way that we approached this design was that the metadata that describes the streamable model, the relationships and the authorization rules, which I just showed you, that's fine. And when you think about the GraphQL API, the first is that we'll add a streaming field to the GraphQL schema. This streaming field will support two things, right? It will support a cursor. The cursor is something that will start the stream, right? And the second is it will support a batch size that the client can use to receive the results in, right? So that gets added, and that's kind of the way it shows up on the GraphQL API. Underneath it, what we do is we back that with this ability to read incremental ranges as efficiently as possible, right? We use subscriptions and WebSockets. I already talked about that a little bit, but two important things here are one, that we want to allow for connection interrupts, whether desired or undesired. So this part is the part that it still has to be kind of worked out and thought about a little bit, right? So connection interrupts can always happen which are undesired. So connection goes off, 3G, 4G is off, or your network is off, or whatever. But sometimes, and this is the part where the back pressure piece becomes interesting, is that, and currently this is the way that we think about it, the client has to manage back pressure at the application layer. I giggle a little bit because that's not necessarily great. But the client has to handle back pressure at the application layer and say, hey, I have a data structure and I'm ingesting this stream and I can't ingest anymore, right? And when the client can't ingest anymore, today, and this has to go through a round of designing, but today the client can just disconnect and say, I'm done. I cannot continue consuming this stream anymore. I'm going to stop here. This is my offset. I remember this offset, but I am done, right? And this is the way that back pressure kind of gets communicated to the upstream service that's serving that stream, right? But with subscriptions and WebSockets and the way that we're delivering it, you want to make sure that it's stateless and horizontally scalable as well. The way that this is important because when we think about WebSockets or streaming kind of use cases, you want to make sure that the nodes that are serving the stream, they are swappable, right? Otherwise, you have to get into things like trying to have a connection that's persistent all the way from the client to the load balancer to the actual container that's serving it out to the actual data system that's serving out that stream, right? So we want to make sure that the GraphQL layer is stateless so that you can have 3 container instances that are running or 10 or 100 or whatever, and it shouldn't matter, right? So that contract has to be stateless, right? So that is kind of the underlying backend. That is kind of what Hasura takes care of, where on a GraphQL API, you're only worried about subscriptions and WebSockets. So just to give this a spin and to see what this looks like. Now, what gets added here is a stream field. And what I can do on the stream field is, let's take a look at the stream field here. One is that we want to let the client choose kind of their batch size. I'm going to just put in 5 here. And their cursor value, right? And this is the state that the client has to maintain. So we'll start off with an ID of, let's say, I'm going to run a load script so that I'm ingesting about 100,000 events per second. So let's run that. Cool. All right. So I'm running a load right now, and let's just get the latest offset value here. So that's the, and you can see that kind of streaming with that appropriate batch size. You can disconnect and connect at any point of time. And all that you have to ensure is that you continue quoting that last value of the cursor, right? So very similar to kind of cursor-based ideas or pagination ideas that you would have seen. Otherwise, very similar API, but the idea is that you can keep streaming, right? So despite the fact that there's a pretty intense amount of load, this is a single instance. We're barely hitting a gig of RAM in trying to do this. Let me see if I can actually bring up an HTOP instance here to see what that looks like. Yep. So that's the system that's serving it out and ingesting. Fairly decent volume that's working, right? So must have ingested about a few million at this moment. So that's kind of what the API looks like. I'm going to give this a pause so that I don't nuke my browser. What I wanted to do quickly was, as I did this, if you folks want to scan this, what you can do is we can try this out live as well. You can see my browser going crazy here. I'm just going to open up that page. Give me a sec. Feel free to just hit that, and I'll show you kind of how this shows up on an app and what that piece looks like as well. So if you hit that with your QR code, what you'll see is a screen that is probably something like this. I'm also going to stop the loading. Yep. All right. So I have two channels here. That's the authorization kind of makes sure that you have access to only one of the channels. So I randomly choose a channel. So one of you will be randomly on red, one of you will randomly be on green. And what you can do is whenever you enter a thing here, it's going to show up on either of those two, right? Whatever message you put in. So yeah, hello from UK. Cool. So please do not use this for NSFW stuff. Just always a little bit scary. So fairly low latency while a huge amount of ingest is happening. And of course, this is just running on a single container, but you can scale this out to, that the scaling is more kind of limited by the range and effectiveness of the range stream query that you can do rather than anything else. Good idea to start investing in Bitcoin when it's at a slump. So solid ideas. So that's a quick look at what the stream API kind of looks like. I think on the, yeah. Now, if you think about streaming, right? There are a few use cases that you'll have, and the question is, how do those use cases map to this primitive, right? So, for example, three that I've encountered fairly often are you want to capture and stream changes that are happening to a data in some underlying data system, right? What is the method of capture? What is the method of streaming? How does that map to this model? You might have a use case where you're thinking about streaming data from data being emitted from another service, another team. How do we take care of that? Or the third, which is on the application side, how do you model an application where you have changes, you have snapshot plus changes, something that is similar to, say, a Google Docs kind of mechanism? Do you use CRDTs? How does all of that get modeled? So the primitive that we have in place, which is that Hasura doesn't take an opinion, or in this case, when we think about streaming, we don't really think about the idea of, we just think about the idea of a streamable model. The streamable model has to either be something that's like a val of changes, or the streamable model has to be something that's, say, in Kafka, or the streamable model has to be a model of CRDTs. But that streamable model has to be that domain-specific model that you want to have. And then the only problem that we want to take care of on the GraphQL side is ensure that the streaming is as effective as possible, but not really get into the business of what the stream model is. Quick question for you folks: when you think about these kinds of streaming use cases, what are the use cases that are top of mind for you folks? And that's something that I wanted to jot down. Any streaming use cases that you folks are seeing inside your workplace right now and things that you're building? Real-time? Yep, real-time log messages, exactly. Yeah, makes sense. And they're being published right now into a system. Where is that being persisted?
Right now it goes to S3 and then get a message that's going to log in there.
Yep. So like basically being able to stream that out over S3 and then get that. That makes sense. One of the things that we're working on is being able to do that with Athena on top of S3 on AWS, so that you can layer the model that you want to have for the log on, and then you can start streaming that. But that's a really good use case for streaming. You probably also have authorization rules where you want to think about who gets to access what logs that are relevant for the user, right? makes sense. Any other streaming use cases that you folks are seeing?
Real-time account balances.
Got it. Okay. Is that more of a live query, or is that more of a stream? Do you want to see all of the point-in-time changes to the account balance, or do you want to see the latest account balance? Yeah. So that's interesting. I didn't talk about that. But for example, here, what you can and this is the way that when we think about subscriptions, right? What we did earlier is when we thought about subscriptions, we were like, there's so much. When we think about a stream, there's so much state to maintain on a client. If we think about it from the live query point of view, we can get rid of state that needs to be stored on the client. It's just that live queries don't work well for cases where you want to stream data. Like you can't use a live query to stream logs, right? Because that result set will keep increasing, right? So, for example, let me see if we can do this. So this is an example of a live query where this is no longer a stream, but this is a live query now that's fetching data from the info model, right? And if I go and change that to a particular value, this is similar to the account balance use case, right? If I go and change that to something else, right, I'm going to get that update here, right? So this is kind of more the live kind of use case, right? This is a slightly different mechanism of thinking about kind of real time, where we're looking at you're only interested in the latest snapshot of that value. You're not interested in any of the changes that have happened in the meantime. So we kind of break that out into like a live queries versus streams kind of idea. There's some overlaps, but that's the right idea. Any other real time or streaming kind of use cases that you folks have been encountering or thinking about? Sorry? A game state? Yeah, that's very interesting. Like a tic-tac-toe like game state, or like a World of Warcraft kind of game state? Like, okay, got it. Yeah, no, that's awesome. That's it's always that's one of the things that we've been thinking about how to model well, because you could think of it as like a live query model as well, where it's like a result set that's continuously updated, right? It's like a matrix of data that you have, and that matrix is just continuously updated. You don't care about like changes that have happened in the middle. You just always get the latest state, right? It's like a tic-tac-toe kind of situation, right? Where you're just getting the latest tic-tac-toe board. So sometimes you can model. That's one style of modeling. The other style of modeling is more the incremental changes that you want to keep streaming to people. I think one of the most interesting things there to figure out, and that's something that we want to think about best practices in modeling this as well, is there's a snapshot plus stream. So what you want to do when you do the first load of the game state is you want to get a snapshot of the current game state, which might be a large piece of data, like might be a few MB, right? But after that, there's a stream. And those changes then might be like bite size. They're like 20 kilobytes, 50 kilobytes, 100 kilobytes of changes that are happening after the snapshot, right? What you don't want to do is start ingesting the stream from the dawn of time to have to replay that log, right, of that entire game state to get that, right? So I think like that's the part that gets very interesting to model when you think about like how do I model a snapshot, and from that point I want a stream. And then you want that to scale out to whatever clients you want, right? So I think that's going to be an interesting. It's an interesting modeling exercise. For us, it'll likely boil down to saying that it's a combination of using a live query and a stream. So you use a live query to fetch the latest snapshot, and then you get a cursor value, and then from that cursor value onwards, you start your stream, and then you start replaying that to ingest that on a game. But those are really solid examples. So these are useful notes for me. Thank you that I'm going to take for. Discussing ideas on how to model this, and that'll be very interesting as well. But that is what I wanted to cover today. Just wanted to show you a quick overview of what the idea is. The idea is that instead of the burden of the work happening here, we've taken a deliberate opinion to shift the burden of the work either here on the stream production side, and that's kind of where the stream models get interesting. But with the core set of primitives, that will work for no matter what streaming use case you have on the client side, right? So that's the idea, or that's the end vision of where we want to get to with this. All right. So would love to get your feedback. You can check this out on GitHub, download the Docker image, point it to a database that you have, start streaming, or do it via Hasura Cloud. It's still very early design stages. Would love to kind of hear how the kind of different streaming use cases you're thinking about, the underlying design itself. We're going to be publishing performance benchmarks, and the way that this is architected, so that if you're thinking about building a streaming use case yourself, on how you can approach building that internally for whatever system you're building to handle kind of a GraphQL stream use case. But would love to hear that, and feel free to reach out on GitHub, Discord, or to me on Twitter. But that is my time. That's all I had. If you want to talk more about streaming and kind of things with streaming, would love to do that after the conversation. Thank you for your time.